a uniform, yes, again it's saying uniform. Uniform means regularly shaped object. A uniform 5-meter long horizontal beam that weighs 350 Newton. Let's draw 5-meter long horizontal beam first. A 5-meter long horizontal beam. This is the beam. Its length is 5 meters. It is uniform, then, which means center of mass and center of gravity is the midpoint. And this is 350 Newton gravitational force, weight of this beam. So I have to draw gravitational force from the center of gravity, which is the midpoint. So this is Fg. 315 newtons. And because the midpoint is the geometric center, so it divides, splits this beam into two. One side must be 2.5 meters. Other side also must be 2.5 meters. So one side, because geometric center, center of mass, center of gravity, divides or splits this beam into two. And it is attached to a wall by a pin. So one end, there is a wall. Say that this is the wall, this end is at the wall, and pin is like a hinge. You are going to fix this beam to the wall by this pin. This is pin. And then this beam can rotate about this beam clockwise or counterclockwise. You can rotate it if you want. Its far end. Far end means if the end away from the wall. Far end is this end. Its far end is supported by a cable that makes an angle of 53 degrees with the horizontal. So there's a cable. Let me draw this cable. This cable is supported, your end is supported by a cable. This is the cable. And this cable is making 53 degrees with the horizontal. Yes, like this. And a 545 Newton person is standing 1.5 meter from the pin. Pin is in here. Let's draw a distance of 1.5 meter from the pin. 1.5 meter from the pin. There is somebody, a person, standing. So a person is standing. Of course, this person must be applying some gravitational force on the beam. How much? How much is this person? 545. This person is applying a force which is equal to 545 newtons gravitational force. There are two gravitational forces. One of them is man's gravitational force. I will say Fg1. Second one is beam's gravitational force. I will say Fg2. So, question. Find the force in the cable. Oh, there's a force in the cable. Cable is like a rope. That force in the cable is called tension. Tension. Calculate the tension in the rope. I will find this tension force, Ft, in the cable. So find the force in the cable, Ft. And also force exerted on the beam by the wall. Yani this wall is in here also exerts a force which is R. So question telling you first find Ft, then find R. If the beam is in equilibrium, so we are going to apply both, we can apply both rotational and translational equilibrium in this question. This is the drawing. We draw this problem. Now remember the steps. First, draw the forces. We already did. Draw forces. So there are 4 forces acting on this beam. One of them is R by the wall on the beam. Second one is Fg1 by the man on the beam. Third one is Fg2, beam itself, weight of the beam itself. And fourth one is Ft by the cable. 4 forces are acting on the beam. Second step. What is second step? Choose axis of rotation. Choose axis of rotation. So then, what is the rule? Choose the location of one of the unknown forces. Which forces are unknown? R and Ft. So I will calculate Ft. That's why I should choose the location of R as axis of rotation. Because question is saying that calculate Ft. I will calculate Ft. That's why I am going to choose location of R as axis of rotation. Axis of rotation. I already determined axis of rotation. Next step, determine distances. Distances from each force. From each force. Let's check them. Normally we determine them. Distance from Fg1 to the axis of rotation is 1.5 meters. Distance from Fg2 to the axis of rotation is 2.5 meters. Distance from Ft to axis of rotation is the length of the beam, which is 5 meters. All distances are already determined. And for torque, calculate torques. Calculate torques. Now, let's start calculating. Torque of R. How much is torque of R? 0. Why? Because R is acting on axis of rotation. So let's calculate with Fg1. Fg1 trying to rotate clockwise or counterclockwise rotation? Fg1, according to this axis of rotation. It produces a
clockwise, negative.
Clockwise rotation, negative. Fg2, also negative. Only Ft try to rotate counterclockwise, which is positive. Let's calculate them one by one. Torque G1. Because it is negative, yes. How much is Fg1? 545 Newton. Distance from force to axis of rotation, 1.5 meters. So let's multiply them. If we multiply them, we will get that result as, let me check how much is it. 818. Yes, torque of G1 is 818 Newton meters. This is torque of gravitational force 1, yani torque of man. Man produces this torque. Now let's calculate torque of G2. Torque G2. It's also negative torque because clockwise rotation causes. How much is the force? 315. How much is the distance from force to axis of rotation? 2.5 meters. That distance from here to axis of rotation only 2.5. When we multiply these two numbers, we will calculate a torque which is equal to negative 788 Newton meters. Torque of G2. I already calculated the torque of G2. Now, last force, Ft. Ft also produces a torque, but in counterclockwise direction. Ft produces a positive torque. Torque of Ft is equal to positive. How much is the force? I don't know. I will calculate. Ft is the force. How much is the distance? Okay, distance is, let me write a little, because I need a space in here. Let me write in here. I'll go down in here. So, torque of Ft is positive. Force is Ft, I don't know. Distance from force to axis of rotation, from here to there, 5 meters, that distance. But in here, one more thing, there is an angle. This force is angled, not others. Others are all perpendicular to the distance, but this is making an angle with the distance of 53 degrees. That's why you should multiply with sine of 53, because we know the equation for torque. F E sine theta. F is Ft, D is 5, a sine 53, angle between the distance line and the force line is 53 degrees. If you multiply 5 and sine 53, you will get 4. That's why torque of Ft will be Ft times 4, yani 4 Ft. So there are 4 forces acting on the beam. I calculated torque of all these 4 forces. Next step is apply rotational equilibrium. So apply rotational equilibrium. Okay, let's apply it. What is rotational equilibrium? Sum of the torque acting on the board, on the beam must be equal to 0. Yani, torque of R plus torque of G1 plus torque of G2 plus torque of Ft must be equal to 0. Torque of R is 0 because acting on extra rotation. Torque of G1, 818. Torque of G2, negative 788. Both are negative, but Ft's torque is positive. 4 times Ft is equal to 0. This operation is negative, let me check, is negative 1,606. Negative 1,606 plus 4Ft is equal to 0. Next step is get this negative to the other side as positive. 4 times Ft is 1,606 divided by 4, answer is 401 newtons. So Ft is 401 newtons. I calculated the tension in the cable, Ft, which is equal to 401 newtons. Now I'm going to show you how to calculate R, the force exerted on the beam by the wall. So R is the question. Now there are 4 forces, Fg1, Fg2, and Ft and R. 3 of them are known. We found Ft, and 1 force is unknown. If 1 force is left unknown, we can use translational equilibrium. We don't need to use the rotational equilibrium, because the rotational equilibrium, you need to calculate the torques, you need to apply the, find the extra rotation and so on. But in translational equilibrium, you only deal with the forces. So I will draw this beam again right here with the data we already calculated with the forces. This is a beam. I don't care what is the distance, because for force, when we are dealing with the translational equilibrium, the distance between the forces are not important. Only thing which is important is what is direction of the force and what is magnitude of the force. So there are 4 forces. I will draw them again. One force is gravitational force, weight of the man. It is in negative y direction. I said it is Fg1, 545 newtons. Second one is weight of the beam itself, Fg2, which is equal to, as I know, it is 315. Yes, 315 Newton in negative y direction. Third force we calculated, which is force in the cable, Ft. And we calculated Ft 401 Newton. And we know that this cable is making an angle with the horizontal 53 degrees. So it is also, this force in the cable is making an angle with the horizontal. And the question is, what is the force on the wall, by the wall on the beam? Here is a R, but I don't know, the question is about R, find R. So the only thing I have to carry in here is in translational equilibrium. So we are going to add all these forces and make them equal to 0. Yani sum of the force acting on the beam is going to be 0. Now, here there's a problem. The problem is that this Ft tension force is not on x-axis, is not on y-axis, it is inclined. So that's why we have to resolve this tension into components, because we can make addition only the forces along y-axis or only the forces along x-axis. That's why I am going to apply this translational equilibrium. Yani sum of the forces acting along x-axis equal to 0, and sum of the forces acting along y-axis is equal to 0. To apply these two conditions, I have to resolve this F2, Ft into components. So I'm going to find them first. What are these two components? So to find the components, you are going to draw XY coordinate system. In here, you are going to locate this Ft on XY coordinate system. And this component is Ftx, X component of Ft, and this component is Fty, which is Y component of Ft, Fty and Ftx. So how can we calculate this Fty and Ftx? Ftx is, it is, last year you learned, Ftx is the adjacent side of this angle. If it is adjacent side, adjacent near side, so we calculate this component by Ft multiplied by cosine of 53. So Ft is 401. Cosine 53 is, let's calculate them, 401 multiplied by cosine 53, which is equal to 241. So if we multiply this, we will get the x component as 241 Newton. Y component is, because it is the opposite side of the angle, because this length and that length are equal, and this is also Fty in length, Fty. So opposite side of a right angle triangle is calculated by Ft times sine of 53 degrees. So which means 401 multiplied by sine of 53 degrees. Now let's calculate this. 401 multiplied by sine of 53, which is equal to 320. So Fty is 320 newtons. Now I resolved Ft into components, horizontal and vertical components. Fg1 is in vertical, Fg2 is also in vertical. So all forces are along horizontal or vertical. So now I can apply this rule. Which rule? Sum of the force acting along x-axis must be equal to 0, and sum of the forces acting along y-axis must be equal to 0. So let's start applying this. R. I don't know, R has two components. My purpose is to find that. So that's why I am going to find for x component of R, Rx. I don't know it, but I will calculate. Fg1. Fg1 is along y-axis. If a force is on y-axis, downward, its horizontal component is 0, because it itself is in vertical. If a force is in vertical, its horizontal component, yani its x component, becomes 0. Fg1 has a 0x component. Fg2, it's also in vertical. If a force is in vertical along y-axis, its x component is again 0. But Ft, next force is Ft. Ft has an x component, which is 241. We already calculated. But in which direction is Ft1? As you see, Ft1 is pointing in negative x direction. If a force indicates in negative x direction, we are going to substitute this force with negative number into the equation. Negative 241. So 1, 2, 3, 4. 4 components of forces are included in this equation is equal to 0. If I take this negative 241 to the right side, it becomes positive. That's why Rx becomes positive 241 Newton. This positive indicates that because we are calculating the x component, Positive indicates Rx is in positive x direction. It is in positive x direction. Then I am going to draw Rx. It is in positive x direction in here. Rx. This is Rx. X component, yani horizontal component of R. How much we calculated? 241 Newton. Now we will do the same thing for Y components. So Ry, I want to calculate Ry. So I am writing Iy. Now Fg1. Fg1 is downward. What does downward mean? It is in negative Y direction. If it is in negative Y direction, we will write this number into equation as a negative. 500 and negative 545. Fg2 also in negative Y direction. So I will write Fg2 into equation again, negative 315. But Fty, look at this one. Fty is in positive Y direction. If it is in positive Y direction, I am going to write it into equation positive. How much is Fty? We calculated to 320. Positive 320 is equal to 0. Then I will do this operation. What is it? Negative 545, negative 315, plus 320. This answer is negative 540. So Ry minus 540 is equal to 0. Get this negative to the right side as positive. So Ry becomes positive 540 newtons. This positive indicates that because we are calculating the Y component, it must be in positive Y direction. So Ry is going to be in positive Y direction. Let's draw Ry. Ry is in positive Y direction. Yes, this is positive Y. And how much we calculated Ry? It is 540. 540 Newton. Now we know both components, X component of R and also Y component of R. So this angle is 90 degrees. I will use only vector addition to find R by using Pythagorean. This is R. This is R. We can calculate R by the equation Pythagorean. It says that R is equal to square root of Rx squared plus Ry squared. So R is equal to root of Rx. Rx is 241 squared. Ry 540 squared, but square root. Now let's find this root of bracket 241 squared plus 440 squared. Close the bracket. You will get the answer, which is 591. So R has a magnitude which is equal to 591 Newton. This is how we calculate R if we find X and Y components. So then I can write that, yes, this R has a magnitude 591 Newtons.